Hello there, this is Wellington with PX5 and today I'll show you how to work with event flags using PX5 RTOS. So in this video we'll run through the synchronization objects, then I'll show you some of the event flag APIs, specifically the create, set, clear and wait. Then I'll show you a 2 minutes demo and share some resources. So event flags are yet another synchronization object available with PX5 RTOS. For a quick recap, all of these that I'm showing here were covered in previous videos with a lot more details, but just as a quick reminder, semaphores that are great for handling of single events, mutexes, great for protecting shared resources, message queues that are great for passing data between tasks, and today we'll be looking at event flags, which are used for multi-condition signaling, but also for the fact that many threads might be waiting for the same event flags, which is pretty flexible. Let's take a look at them. Event flags are not part of the pthread API per se, but they are quite useful in embedded real-time programming. These objects are represented by a single bit in a 32-bit word, which allows to a maximum of 32 events per event flag group. Then threads might be waiting for one of the events they specify, but more than one, they might be waiting for all the events they specify. Then when a thread sets an event, all threads that have their event requests satisfied are resumed. And then finally, events that satisfy a suspended thread's request are automatically cleared, and of course this is a behavior that can be changed. ISRs are also allowed to set event flags via this API. There are plenty more of event flag APIs. Make sure to check the user guide for the full list. Before we can use an event flag, we first need to create it. And to do that is really simple. We're going to be using the pthread event flag create API by passing the handle of the flag to create and optional event flag attributes. Once the event flag is created, we can now set this event flag by passing the handle of the flag to set and then a bitmap of the event flags to set. Remember that 32-bit word. We can clear an event flag by using the event flag clear API by just passing the handle of the event flag to clear. And we can use this API to get the thread for waiting for specific event flags. To do that, we're going to use this API and then passing the handle of the event flags group, the requested event flags. Then we're going to be using this parameter here to say if all events or any of the events should be satisfied so that this thread might wake up again. And then an optional parameter here that is the destination of where to return the actual event flags that satisfied the request. Let's take a look at this sample. Well, here, as always, main starts running and creating variables, thread handles, and the memory area. Then here in line 5, we get to start PX5 RTOS by providing a random number for a pointer data verification, memory area, and the size of that memory area. This will convert main to a thread running with the default priority of 16. And next, we're going to be creating an event flag by passing the handle to the event flag. Now we have the event flag created here. Notice we're representing only the lower part of this 32-bit value for this event flag, just for simplicity. And then next, we're going to be creating another thread, the child thread. And all we need to provide is a handle to this thread and the entry point for the thread, which is the function to be called by this thread. Here we can see the child thread is created, also with the default priority of 16, which is the same as main, which is ready and waiting to run. At this point, main yields, allowing the child thread to run. Now the child thread is executing and it will increment its counter. We see here now the counter is at 1, and then this child thread will wait until the condition set for this event flag is satisfied. This thread will be suspended until it happens. So we see now this thread is blocked. Main will resume and increase its counter. Now we see here the counter has been updated, and then main will set the event flag with this value of 7. So after setting the event flag, two things will happen. The first one is that all threads suspended waiting for this condition will be ready to run, which is the case for the child thread. And the second thing is that the event flag will be consumed by the thread, clearing the first 2 bits. Child thread will be ready to run, but it won't take over since it has the same priority as main. But main will now yield. The child thread resumes and is now ready to increment its counter variable. You see here it's incremented its counter variable, and then it will wait again until the condition set for the event flag is satisfied. Once again, this thread will be suspended until it happens. Like so, with the child thread blocked, main will resume and increment its counter variable again. It will be setting the event flags to the value of 7 once more. And just like before, threads waiting for this condition to be satisfied will be ready to run, and then they will also consume the event flag, like so, allowing child thread to run. It won't take over because of the priority, but then main will yield again, and then just continue to going on and on. Well, now you should give it a try. Take a look at PX5RTOS.com, download the sample, and then you can run this event flag sample I just showed you. If you have some development boards around, it's always better to test with real hardware, but you can also run with the simulation, and we do have samples for a number of different hardware, so give it a try. So that's the demo we had for today. As always, if you want to learn more, take a look at our website, PX5RTOS.com. Make sure to check it. You can always email us with questions, requests for information, or a quote. Thank you for your interest.